प्रकाशस्य रूपमधिकम् प्रच्छन्नगुप्तं धनम् विद्याभोगकरी यशः सुखकरी विद्या गुरुणा गुरुः विद्याबन्धुजनो विदेशगमने विद्या परं दैवतम् विद्याराजसु पूज्यते न तु धनम् विद्याविहीनः पशुः विद्या प्रशस्यते लोकैः विद्या सर्वत्र गौरवा विद्यया लभते सर्वम् विद्वान् सर्वत्र पूज्यते ज्ञानेन सदृशं पवित्रमिह विद्यते न हि ज्ञानेन सदृशं पवित्रमिह विद्यते न हि ज्ञानेन सदृशं पवित्रमिह विद्यते
Dr. Vishal Borude serves as an assistant professor at Mulund College of Commerce since 2014. He teaches across multiple levels, including the Information Technology program as well as the B.Sc Computer Applications and B.Sc Data Science programs, covering undergraduate and postgraduate students. Dr. Vishal Borude completed his Ph.D. in Computer Science in 2022. His doctoral research titled Animal Classification and Recognition Using Deep Learning with Convolutional Neural Networks showcases his deep expertise in artificial intelligence. In addition to his role as an educator, Dr. Vishal Borude teaches students of a range of advanced courses, including Scala Programming, programming with Node.js, Advanced Excel, Robotic Process Automation, and Ruby on Rails. His extensive knowledge in these areas greatly enhances the curriculum and provides students with valuable skills in emerging technologies. Dr. Vishal Borude is also a resource person, having been invited to speak at seminars on mobile application development, business intelligence, and cloud engineering, and appointed as a resource person for industrial training on mobile application development using Dart and Flutter. His research interests include artificial intelligence, cloud computing, blockchain, and data science. Dr. Vishal Borude has co-authored the SY-BSc Applied Mathematics textbook and published several research papers in UGC Care and Scopus listed journals. Dr. Vishal Borude's commitment to both teaching and research makes him a significant contributor to his field. Welcome, Vidyavachspati, Dr. Vishal Borude.
Namaskar. Myself Dr. Vishal Borude. First of all, I would like to extend heartfelt thanks to the Parle-Tilak Vidyalaya Association for providing such wonderful platform to present our research work. My PhD topic was Animal Classification and Recognition using Deep Learning with Convolutional Neural Network. Computer vision is a field of artificial intelligence that enables computers and systems to derive meaningful information from the digital images, videos, and other visual inputs, and take actions or make recommendations based on that information. Computer vision algorithm analyze certain criteria in images and videos and then apply interpretation to predictive or decision-making tasks. Today, the deep learning techniques are most commonly used for computer vision. The deep learning methods can achieve the state-of-art results on challenging computer vision problems such as defect detection, image labeling, face recognition, object detection, image classification, object tracking, moment analysis, cell classification, and many more. We must be knowing the top applications of this deep learning are the self-driving cars, the natural language processing, image and speech recognition, visual assistant, and etc. Now, first of all, we have to understand what is the basic difference between the image classification and object detection. The image classification is a deep learning task for determining which objects are in the image or video. It refers to the training deep learning models with the intent of finding which classes or the objects are present in that image. Classification is useful at yes or no level decision whether an image contains an object or not, whereas object detection combines classification and localization to determine what objects are in the image or video present and specify where they are in the image. It applies classification to the distinct objects and use bounding boxes. As you can see here, we have the classification and object detection. Now, why there is need to have the classification and recognition done through the deep learning or AI techniques? There are so many disadvantages when we are using the traditional methods for recognizing and identifying the animals. So, which are the techniques that we are using to identify the animals traditionally? Ear tagging, ear tattooing, number tagging, branding, and ear notching. In the ear tagging, an ear tag is a small object that made up of plastic or metal that is imposed in the ears of the animals by the way of the applicator. In the ear tattooing, the animal must create the numerous tiny holes in the ear skin in the shape of letters or the numerables, which are filled with the tattoo ink. Number tagging. The number tagging is accomplished by attaching the metallic labels to the neck links and looping rope around the neck of every animal. In branding, we have hot instrument imprinted with the number of sign is softly placed against the animal's body, typically backside of the animal. Now, we have certain disadvantages when we are dealing with the traditional approaches. To overcome such problems, we have the solution in the deep learning form. Traditional practices are temporary and are so painful and can injure the animal permanently. Hence, the automatic identification is so useful and helpful that does not harm the animal at all. The biometric identification we have, but here also we have some hurdles, the problems. We need to collect the data from the animals, the data like the iris print, the nose print, the retinal pattern, the facial pattern, the texture of patterns of a color, etc. Through this data, we can get the data set. There are many obstacles to overcome in order to make the biometric system. The first obstacle is gathering the data from the animal. Second obstacle is animal should remain stable during the recognition. Otherwise, system will not be able to recognize the animal properly. To address this obstacle, we have the solution in the deep learning form. The primary motivation of our research work is to classify and recognize the animal using DL technology. And for this work, we have taken the Indian cow breed. So we have selected the animal as Indian cow. The dataset for the cow classification is freely available on the internet, but there is no special database available especially on the Indian cow breeds. So when we are using foreign cow breed dataset to classify and recognize the Indian cow, we may receive the poor accuracy, and hence we have prepared the Indian cow dataset for classifying the Indian cows. The proposed Indian cow dataset has two classes. One is cow class and other is non-cow class. The cow class has the images on the Indian breed cows, whereas non-cow class has the cat, dog, and goat images. To solve the recognition problem, we have prepared the primary dataset on the Indian cows. This dataset has 4 classes of 4 different Indian cows. The classification problem is solved by using SSD MobileNet V2 COCO model. It is advanced deep learning model only. Recognition problem is solved by using VGG16 model. So here is the block diagram of proposed model. We have to provide the input image. The trained model will locate the object where that object is present in the image. It will classify that object. After that, it will recognize, identify that object. The suggested methodology will be beneficial in livestock, care zoos, and the other sectors requiring animal monitoring. However, we recommend that presented model be used to address the issue of animal classification and recognition in animal husbandry industry. Farmers will be benefited from the suggested approach for the following reasons. The first is counting of animals will be done automatically. Identify individual animal automatically. Verification of ownership of an animal. Detailed information of missing animal will be provided. Objective of my research work: to analyze existing animal classification and recognition systems, to propose novel animal classification and recognition system, to overcome limitations of existing systems, to perform comparative analysis of proposed method with the existing methods. Scope of research work: the proposed model is useful to detect, classify, and recognize animal from the given input image. We propose this model in animal husbandry sector. We propose to classify and recognize cattle, dog, cat, and cow. Currently, animal biometric identification is being used to indicate animal, but in the majority of cases, it is so difficult to collect the information from the animals to store in the database and keep animals steady in front of the system at of recognition time. The existing classifier and identifier show poor accuracy rate when 2 or more animals have the same texture of body pattern or the body color. Now let us have a look on basic architecture of CNN. There are 2 main parts of CNN architecture: a convolutional tool that separates and identifies the various features of the image for analysis in the process, and it is called feature extraction. So first of all, we can extract the features which exist in that object through this convolutional tool. After that, we have fully connected layers that utilizes the output from the convolutional process and predicts the class of the image based on the features extracted in the previous stage. Importance of dataset: dataset contains a lot of separate pieces of data, but we can use to train and model with the goal of finding predictable patterns inside the whole dataset. Mostly the dataset has 3 parts: the training, testing, and validation. Training dataset: the training data is essential because it is used to help a program to understand how to apply the technologies like neural network to learn and produce the sophisticated results. Validation dataset: the sample of data used to provide an unbiased evaluation of the model fit on the training dataset while tuning the model hyperparameters. Testing dataset: the samples which are used to provide an unbiased evaluation of final to fit on the training dataset. Now let us talk about the proposed dataset. We have prepared 2 different datasets, one for classifying the Indian cow breed and second for recognizing or identifying the cow. We have prepared a secondary dataset on Indian cows. The purpose of preparing this dataset is that there is no special dataset available on the internet for the Indian cows. So the trained model on this dataset could give a better accuracy result. The Indian cow images for this dataset have collected from the internet. The cow images belongs to the different Indian cow breeds which are found in the different regions of the India. This dataset has 2 classes, cow and non-cow. The non-cow class has the images of dogs, cats and goats. Now let us see the bifurcation of the animals in the proposed Indian cow dataset. So overall 1688 images are used. Amongst that 850 are cow images, 314 are the cat images, 279 are dog images, and 245 are the goat images. So for training dataset we have used 1263 images. For testing we have used 425 images. The count of annotated images are shown here. We have used label IMG tool to labeling the objects present in the images, and this is useful step when we are testing the model, the deep learning model on the proposed dataset. So total annotated objects are 3288. Proposed Indian cow dataset for the recognition model. We also have prepared the primary dataset on the Indian cows to train the deep learning model to recognize the specific cow. The images of 4 different cows are used to prepare this recognition dataset. We have named these cows as cow 1, cow 2, cow 3 and calf. The same classes are formed in the dataset. The trained CNN model on this dataset will be able to recognize the cow belonging to either of these classes. Now let us see the images that we are used in the classes. So for cow 1 class total 27 images are taken. There is a second cow whose class name is cow 2, so 27 images are taken. Third cow, the class of that cow is cow 3, 22 images are taken of the same cow, and there is a calf. So total 10 images of that calf is taken. So overall we have 86 images in the dataset. Experimental work. As we have selected Google Colab GPU for testing the model, we had experienced more processing speed for training the model. Very first training step is 0. As training continues, the training steps got increased. At same time, the loss value got reduced. Initial loss was 15, and we have trained the model till 15,007 step. Loss value we received on this step is 0.05. Further, we downloaded this model and we have implemented this model on the local setup. Further, we call Jupyter Notebook from the Anaconda prompt for the purpose of testing the model. Testing of trained model. The trained model is not only detecting the object in the image, but also predicts the class of the detected object with confidence value. We have given the different images to check the accuracy of the trained model. The images with the single cow object, multiple cow objects, single non-cow object, multiple non-cow objects, cow and non-cow objects are tested in the model. So different combinations we have taken basically to test the model. The model has shown the good accuracy result after the testing. So here are the few images. The model has accurately identified the object and predicted the appropriate class. Here are the images where the multiple objects are present and still the model is correctly identifying the object with the confidence value. Now there is a wrong prediction obtained from the trained model also. So here are the few images of it. And why this has happened? Because the model finds the similarity between the objects which present in the image with the existing pattern of the object that is there in the model. So that is why this prediction happens, which is wrong. Model accuracy graph. We also have prepared the accuracy graph of model. On every 1000 training steps, we have tested the model. We recorded the accuracy value. On 1000 step, accuracy of the model was 45%, and accuracy is increased as the training steps increased. On 5000 step, the accuracy reaches to 60.45%. On the step number 10,000, it reaches to 79.85%. The accuracy of the model on 15,007 step is 90.69%. On this step, we stopped the training. We have also calculated the class-wise accuracy. For cow class, accuracy is 88.42%, and for non-cow class, it is 97.05%. Now, we have the second problem, the cow recognition model. How this model is useful to recognize or to identify the cow, the individual cow. To recognize the individual cow, we have trained VGG16 model on our primary cow dataset. There are various ways to recognize the animal automatically, like by applying the biometric method, using RFID, etc. But there are some issues with these methods. For biometric method, animals can be recognized by using its unique features like iris print, muzzle print, body color pattern, etc. While doing the recognition using biometric, the animal should be close to the system and should be stable so that the appropriate information get captured by the system. To overcome these challenges, we have proposed the deep learning method to recognize the animal. We have trained the VGG16 model on our prepared primary dataset. This dataset has 4 different Indian cows. The trained model on this dataset is recognizing the cow by predicting the class of the cow. The class label could be like ID of that cow. This is useful to identify the ownership of the animal, monitoring the animal, and the same model could be applied in the different sectors where the animals need to be monitored. Training of VGG16. On Google Colab platform, we train our model using our created primary dataset up to 1000 steps. For training, we made use of GPU, Graphics Processing Unit. We got the trained model size as 2.86 GB. On the Google Colab platform, we have tested the accuracy of the model. The input image of the cow is given to the trained model and it predicts the class of the given detected cow. There is a probability vector to predict the class of the cow. The value 1 in the vector implies the class of the detected cow, while 0 means the cow does not belong to that particular class. So here are the few results. The vector shows wherever 1, that cow is getting predicted by the model, recognized model. So in the first image, the vector shows 1 0 0 0. It means this cow belongs to the cow 1 class. It means the ID of this class is 1. Then we have next vector. The value of this vector is 0 1 0 0. It means the model has identified this class with ID 2. So it belongs to cow 2 class. Similarly, we have cow 3 and calf. Now there is a wrong prediction also. Why this wrong prediction has happened? Because the model finds the similarity between the existing cows and then these images. Accuracy of the model. We tested trained model's accuracy by presenting it with 10 pictures of different animals, and results were as follows. According to the calculated results, the model successfully identified 28 out of 40, resulting in 70% of accuracy rate. Limitation of research work. The current study demonstrates low or wrong prediction performance of small size animals in the image. The model predicts the class of the animal which is not even used in the dataset. If the model finds the similarity between the body patterns, colors between the two animals of the different classes, then both animals is predicted under the same class. All the species of Indian cow breeds are predicted under one class, that is cow class. Future scope. The current secondary dataset is formed by collecting the images of Indian cows. All these images are categorized under one class, that is cow class, and cat, dog and goat images are collected to form the non-cow class. In future work, this dataset will be updated and cow breed wise classes will be formed. More images for all the classes will be added in both the data sets so that the trained model on the data set will show the improved accuracy. New data set of the Indian wild sector animals, endangered animals, zoo animals, farm sector animals will be proposed so that the researcher will be motivated to study these species by deep learning approaches. Thank you.
ज्ञानेन सदृशं पवित्रमिह विद्यते न हि ज्ञानेन सदृशं पवित्रमिह विद्यते न हि ज्ञानेन सदृशं पवित्रमिह विद्यते